Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hakimi bin Adnan and my matrix number is 2212529 and we are from group 2 Data Science section 1 and today we are going to presenting our project which is called the sentiment analysis across all social media platform by trending hashtag. So our group members consist of 4 people, me, Falikh, Syabil and also Sakhawi. So we are going to continue firstly to the background.
Assalamualaikum. My name is Mohd Fikri bin Fauzi with the matrix number 2211635 and I'll be introducing you to the background of our project here. So basically, firstly, social media is a real-time emotion outlet where social platforms like Twitter, Facebook, Instagram, and also TikTok have become spaces where a lot of users express their real-time emotions and also opinions. And there's also hashtags which not only categorizes content but also reveals the public sentiment and also the collective attention around events, products, and also issues. So next is sentiment analysis as a powerful analytical tool where using NLP techniques, it can enable the automatic classification of social media posts into positive, negative, and also neutral categories. So from here, it helps us in gaining insights into public opinion and also the trends from massive volumes of unstructured data. And lastly is the solutions in sentiment analysis where several algorithms are used such as logistic regression, CFIDF factorization, and also SMOD to improve model performance and better capture emotional trends from hashtag-based discussion.
Hi, I'm Sakhawi, 2216715, and now I will be presenting my part. So first, here is the problem statement for this project. So first, as we all know, social media is very, very vast. People are posting everything in a span of a few seconds, and sometimes all these posts actually followed by hashtags, and all these hashtags sometimes means the feeling that the posters are trying to convey to the to the public. So what we are going to do is that we will analyze all the hashtag to see what feelings are the posters feels. But in order to analyze this, we actually have to analyze the social media data, which is very, very sometimes unstructured, noisy, and sometimes imbalanced. Yeah, all this might affect the the accuracy of the er- end result. Yeah, and many existing sentiment analysis m- models actually right now focus on only one social media, for example maybe Twitter only or maybe Facebook only. And next, sometimes all this research does not even address the class imbalance efficiently. So in this project we are going to use logistic regression and TF-IDF and SMOD for the class imbalance, and also we will be analyze all of the social media data from multiple social media platforms such as Facebook, Twitter, and also Instagram.
Warahmatullahi wabarakatuh. My name is Syabil Zahri and my matric number is 2124767. Now I proceed to the research question. For our study, we focus on 3 main research questions. Firstly is what is the distribution of sentiment, whether it's positive, negative or neutral, across trending hashtags on social media platforms like Twitter, Facebook and Instagram. Secondly, we ask whether machine learning can accurately classify user sentiment just by analyzing the text features in those posts. And lastly, we wanted to understand how techniques like text vectorization and class balancing, especially using TF, IDF and SMOD, can influence the performance of our sentiment classification model. So for these 3 questions guided our methodology and help us evaluate how effective our machine learning approach is in making sense of public sentiment online.
So we continue to the hypothesis. So we have 4 hypotheses. The first one is there is a significant tendency for social media users They express positive sentiments while engaging with trending hashtag across all the social media platforms, for example, Twitter, TikTok, Facebook, and many more. The next hypothesis is the performance of the sentiment classification model improves significantly when class imbalance is addressed while using the SMOD technique. The third one is the model, which is the logistic regression. When combined with the TF-IDF factorization, can achieve a sentiment classification accuracy of at least 85%. And last one is there is a significant relationship between the level of engagement, for example, the like, retweets, comments, and the sentiment of the post.
So let's go to the research objectives. Our research objectives are designed to guide each step of the project from the data collection to model evaluation. First, we aim to collect and analyze a labeled data set of social media posts that include trending hashtag. Second, we apply natural language processing techniques, specifically TF-IDF, to pre-process and transform the text data into numerical form. Then we implement logistic regression as our main classification model for sentiment prediction. To ensure balanced predictions, we apply smooth to handle class imbalance, especially for minority sentiment like negative posts. And finally, we evaluate our model performance using metrics such as precision, recall, F1 score, and accuracy to ensure reliability and fairness across all sentiment categories.
Next is the research significance, where firstly, it helps us in understanding the public sentiment through hashtags, where the study highlights how popular hashtags reflect the collective public emotions and opinions. And there's also automatic interpretation of emotional responses, which helps in uncover patterns in users' behavior and also online interactions. And it's also crucial for analyzing if there's any social discourses. So next is enhanced sentiment classification with machine learning by applying logistic regression with TF-IDF and also handling class imbalance via SMOD. Our research improves in sentiment model accuracy and also fairness. This also contributes to more reliable and also precise sentiment detection in real-world social media contexts. And lastly, it's broad and practical and societal impact where it demonstrates on how sentiment analysis can also support digital marketing, public opinion analysis, and also data-driven policy responses.
And next for the literature review. So in this paper, we actually use 11. First of all, Ahmad et al. Actually did compare the traditional TF-IDF and with the transformer models such as BERT in short text sentiment analysis on Twitter. And the result shows that the combination of TF-IDF with logistic re- regression gives the highest accuracy with a percentage of 89%. And next, Patel and Lee actually removed the stop word in social media NLP, which increased the discriminative power of the FIDF features by 14%. And next, Zhang et al. Assessed the performance of this mode on high dimensional NLP data, and the result shows that Smooth managed to improve the F1 scores for minority classes by 22% compared to random oversampling. And next, Gupta and Wang did an analysis regarding class imbalance technique for sentiment analysis, and they find out that Smooth actually enhanced uh, the recall for undersampled sentiment classes by 18 to 27%, but if combined with logistic regression. And as we all know, logistic regression is very, very popular for text classification since Chen and I use logistic re- re- regression to compare its its result with SVM and naive bias, and the result shows that logistic regression plus TF-IDF have the highest accuracy of 91%. And lastly, Nguyen et al. Conduct an analysis on sentiment model interpretability through the application of SHA. And It actually provide that the model's best performing TF-IDF features are closely aligned with human annotated sentiment lexicons. And next, we all know the hashtag actually plays a huge role as topic identifier since Kumar et al. Actually discovered that 68% of trending hashtags are very, very close to polarized sentiments. For example, hashtag climate emergency. This hashtag actually considered as negative, while hashtag love wins, and this hashtag considered as positive. Rodriguez and Liu took a step further in their research by developing a combination of TF, IDF, and word-to-vec model for real-time sentiment hashtag tracking on Facebook and Instagram. And it actually gained an accuracy of 87% on the classification in the result. We also have to understand the importance of the correlation of user engagement and sentiment as this will be useful for maybe marketing and PR. First, I'll conduct a study on tweets which they established that negative tweets with hashtag garnered 2.3 times more retweet, but it has 40 less likes compared to positive tweet. And Banzal and Kim looked further into the time pattern, which they discovered that peak engagement hours are around 7 to 9 p.m., local time for emotionally charged posts. The finding provide insights into understanding between the correlation of a time when a time a post is posted and the sentiment and the engagement metrics. And last but not least, Almeida AR reviewed end-to-end social media sentiment analysis and find out that the combination of TF-IDF vector logistic regression and using Mohd actually very very good for a small to medium sized data set.
Assalamualaikum, my name is Hakimi. My matrix number is 2212529 and I will explain about the methodology part of our project. So this is our flowchart and I will explain it one by one. So the first one, we actually find a dataset from online platform which is Kaggle, and then we load into our Colab, Google Colab, okay, and then the next one we actually proceed to the data cleaning process. So the data cleaning process, we actually done a lot of things. For example, the first one, we check any duplications and also missing values in our dataset. So based on our inspection from our Colab, it shows that our dataset didn't have any duplications and missing values. So we proceed to use the TF-IDF vectorization and also smooth technique for our further cleaning process in the dataset. Next, we proceed to the TF-IDF, which is term frequency document frequency, and also the smooth technique, which is the synthetic minority oversampling technique. So the first one is basically TF-IDF. So TF-IDF is used because we want to convert the textual data to the numerical vector, because in our dataset, our dataset is basically fully of the textual data. So we want to convert the textual data, specifically the text column, to the numerical vector, because we want the logistic regression or our model to train better in the training model and also the prediction later. So in the TF-IDF, it is actually have two important components, which is the first one is TF, which is the term frequency. So it is used to measure the frequency of a word in the dataset. So when it measures the frequency, it will capture the importance of a word in the dataset. So the second component is IDF, which is the document frequency. So after measure the frequency, IDF will help to scale down the importance of words that appear in the dataset. For example, if a word that is basically unique in the dataset, which is not frequently used in the dataset, it will give more weight to the word. But if the word is basically less used, is more frequently used in the dataset, it will given less weight. So for example, if in our dataset, just for example, if a word happy is frequently used, so it will given less weight, and if the word happy is basically not frequently used in our dataset, it will be given more weight. Okay, the next one is SMOD. SMOD is basically the synthetic minority oversampling technique. So this technique is basically we want to use this technique because we want to help our dataset issue, which is we have a imbalanced dataset. So due to the imbalance in the dataset, which is an imbalanced dataset, can cause the model to favor the majority class, which is can resulted in a not accurate result. So this mode will balance the class distribution. How? So this mode basically it will generate synthetic sample of minority classes. For example, if in our dataset we actually have a lot of examples of, or we have a lot of sentiment or textual that lead to the positive sentiment, so it will be biased because there are a lot of positive sentiment than the negative and neutral. So to balance these issues, we use this mode, and this mode will generate the synthetic sample of minority class, which is it will synthetic the negative sentiment. So this will allow the model to learn the pattern successfully without any bias, and inshallah it will provide the more accurate and precise result. So we continue to the data wrangling process. In data wrangling process, we actually do three things, which are first one, we drop two columns. So in our data set, we have a 6 column overall, and we drop two columns, which is called unnamed 0 and unnamed 1, because these two columns are irrelevant and didn't help us in our predictions or analysis. The second one is basically we use the stripping because we want to avoid any error during the model development. So we remove the white space by using stripping, especially in the platform and also country columns. So the next one is basically we grouping the sentiment. So in our dataset, they provided a lot of sentiment. For example, the happy, sad, excited, enjoy, and so on. So there's a lot of sentiment. So to ease our process in our prediction and also the model training, we manually group all the sentiment into 3 classes, which are the positive sentiment, negative sentiment, and also neutral sentiment. So we will predict and classify all the sentiments into these 3 classes. Next, we proceed to the EDA, or exploratory data analysis. So we visualize 2 diagrams, which is the sentiment distribution and also heat map correlation. So for the sentiment distribution, we actually visualized it before and after the SMOD technique. So this diagram is basically after the SMOD technique. However, we can see that the positive sentiment is way higher than both negative and neutral, but it is way better result than before we are using the SMOD technique. So this is the distribution. So the next diagram is basically we are showing the heat map correlation between all the numerical values or variables in our dataset. So they are retweets, likes, year, month, day, and hour. So when we actually visualize this, we want to observe any relationship or correlation between variables that can help us in our analysis or prediction. However, we can see here that there are no relevant correlation between all these variables. So we will proceed to our analysis later. Next, we proceed to the model development. As I said just now, we are using the logistic regression from the sklearn for our model. So we use X and Y. X is basically from the text, and Y is basically the target variables, which is the sentiment. So we are using the text to predict the sentiment based on the text. So this is the model development, and then we integrate the TF-IDF vectorization into the model because we want to convert the textual data to the numerical values so the model can learn better, because logistic regression is basically learning using the numerical values. We proceed to the data splitting and model deployment. So for the data splitting, we are using the train test split from the sklearn. We split the data for 70 and 30, 70% for training data and 30% for testing. Next, we move forward to the model training or feed the model or train the model. So basically, we are using the logistic regression and with the maximum iteration of 1000 with the integration of the TF-IDF vectorization. After successfully train the model, we actually do the prediction. So y, as you know, is the target variable, so it's using the x, which is the text, to predict the sentiment. So these are the results, which are classified into the three classes, which is either it is positive sentiment, neutral sentiment, and negative sentiments. So that's all from the methodology, and for the result, it will be discussed by my friend.
Thank you, Kimi, for explaining the methodology. Alright, so let's dive into the result of our sentiment classification model. First, if you look at the sentiment classification report, you can see that our model performed really well across all three classes: negative, neutral, and positive. For negative sentiment, the model scored an impressive precision of 0.99 and F1 score of 0.69, meaning it was really accurate when detecting negative posts. For neutral and positive sentiment, the scores are also quite strong, both having precision and recall around 0.86 to 0.90, which show that the model was consistent and balanced. Overall, we got a solid accuracy of 90% with macro and weight average also hitting 0.9, which means performance was equally good across all sentiment types, not just one. Now, if we move over to the confusion metric, this show how many posts the model predict correctly and where it made mistake. We can see that most of the prediction were correct, especially for negative and positive. There was some mix up between neutral and positive sentiment, which kind of makes sense since those can be hard to differentiate, especially in short social media posts. Then in the learning curve chart, we look at how the model performs as we feed it more training data. The blue line is the training score and the green one is the validation score. As you can see, the validation accuracy steadily increase and stay close to the training score, which is great sign. It means our model is learning well and not overfitting. And the last one is the ROC curve. It's used to evaluate how well our models separate in different sentiment classes. For each sentiment class, we have an AUC score above 0.95, which is considered excellent. This confirms that our model is not just guessing, it can confidently distinguish between positive, negative, and neutral sentiments. So in summary, we just logistic regression, TF, IDF, and smooth. We were able to get really strong and fair result. And this proves that even a simple model can perform well when the data is prepared properly.
And moving on to discussion, where our model shows a strong model performance with logistic regression and TF-IDF, where our model achieved 90% accuracy and also strong performance across all matrices, which are precision, recall, F1 score, and AUC. And TF-IDF effectively captured sentiment nuances by focusing on significant terms and also downplaying common stop words. Next is sentiment distribution reflects the social media behavior, where our dataset was mostly positive and followed by neutral and negative sentiments. And this can reflect how hashtags are being used in celebratory, promotional, or community-based contexts, but still allow space for diverse opinions, whether it's negative or neutral. And lastly, Smart improved the fairness and minority class detection, where it effectively solved the problem of imbalances between the classes and calculated better detection of minor classes of sentiments, mostly being the negative ones. And lastly, it shows that thoughtful pre-processing, namely and vectorization plus resampling, can and plays a vital role in accurate social media sentiment analysis.
So in this project, we just use Facebook, Instagram, and Twitter. And so in the future, we may also expand it to add maybe TikTok or Reddit as this will improve the g- generalizability of the findings. And next, we may also include the deep learning models such as BERT or maybe LSTM to further understand the context of the post. Maybe it will identify the sarcasm or maybe the subtle sentiment. And lastly, more exploration on the real time sentiment tracking might also be valuable for the organization that seeks for immediate feedback for their PR. So, in conclusion, in this project, we actually managed to show that by combining all the TF-IDF vector, logistic regression model, and smart for the class imbalance, we managed to achieve effective sentiment classification across multiple social media. And this model managed to achieve an accuracy of 90% with very balanced precision and recall scores. And lastly, this result can also be used for further insights, maybe through its decision making across the field, maybe such as marketing or maybe public opinion analysis. And I think that's all from us. Thank you.